Now we're going to look at linear programming, the graphical method. The picture that you see should look familiar. This is what we have been doing, where we have been graphing linear inequalities, and we've been finding the feasible region and the corners. So the fundamental principle of linear programming: if a linear equation of the form z equals ax plus by is evaluated at each point in the closed polygonal region, which is my feasible region, the maximum and minimum values of the equation occur at the vertices of the region, or the corners. So what that is saying, if I have to find a maximum or minimum value, it's going to occur at my corner points. And this is why you were asked to list them in the last section. So I need you to go and find the feasible region for this and find the corner points. So I need you to pause me and see if you end up with what I do. So go ahead and graph it. So first one I'm going to graph will be the 2x plus 3y less than or equal to 100. Change it to an equation and find my intersection points, my xy intercepts. And I also do that for this one. And what I ended up with as my feasible region was this. Hopefully you did too. If you'll notice, I did label because these values are getting sort of large. So you need to really label your graph. Also notice I did indicate an odd possible corner here, which, well, actually it is a corner. Okay, so when I list my corners, I have got 4. I've got my origin. I've got this, which would be 0, 100 over 3. I've got this one, which is 40, 0, and I've got this where they intersect. So see if you ended up with this list as your corners. Let's see, I think I have that matrix in. Let's see if I have it. That's it. So let me do my RREF. To that matrix. Please don't put that down. It does look like it's very close to 28, and it is under 15, but remember you can go frac this. So you need to frac it because it's more exact. So there's that 200/7 and 100/7. Now here's the new part. This is where, now even though they give you the objective function right at the very beginning of the problem, it's going to be almost the last thing that you do because you don't know the corners yet. So now with my objective function, notice I've got an x and a y, so I'm going to be substituting my x's and my y's into this equation and see what happens. So if I put 0, 0 in, I end up with z equals 0. If I put the 0, 100 over 3 in, you should end up with 800 over 3, or 266 2/3. 40 and 0, I'd have a z value of 400. And if you put this one in, let's see, I've got 10 parentheses 200 divided by 7 plus 8 parentheses 100 divided by 7. I end up with 400 on that one. Okay, so now they wanted us to maximize. Well, you look down through here, and my maximum values is actually is 400. So I've got a tie. So this function can be maximized at 2 corner points. My maximum value is 400, and these 2 corners, 40, 0 and 200/7, 100/7, would give me this maximum value. Okay? So now, the next thing, word problem. So let's see if you can go and set this word problem up. Pause me, set it up like we've done before. Read carefully through and see what is it they're wanting you to find, because that's your column headings. So I'm going to go ahead. John Brown's Engine Reconditioning Company works on 4- and 6-cylinder automobile engines. Each 4-cylinder engine requires 1 hour for cleaning, 5 hours for overhauling, and 3 hours for testing. Each 6-cylinder engine requires 1 hour for cleaning, 10 hours for overhauling, and 2 hours for testing. Okay. The cleaning station is available for at most 9 hours per week. The overhauling equipment is available for at most 80 hours per week. Testing equipment is available for at most 24 hours per week. So for each reconditioned 4-cylinder engine, the company makes a profit of $150, and for each 6-cylinder engine, it makes a profit of $250. The company can sell all the reconditioned engines it produces. How many of each type should be reconditioned to maximize profit? Again, how many of each type? What are they referring to? They're referring to the 4- and 6-cylinder automobile engines. So that's going to be my column headings. I'm going to let X equal the number of 4-cylinder and Y equal number of 6-cylinder. Okay? So it says each 4-cylinder engine requires 1 hour for cleaning, 5 hours for overhauling, 3 hours for testing. So that right there gives me my row headings, because this is about 4-cylinder engines. I put the information under here. So let me get rid of these. That's going to be my cleaning, and the order they give it is the order I put it down. There's overhauling and my testing. So they said 1 hour, right, for cleaning. Okay, you didn't move. There's 1 hour. So on this one, the overhauling, 5 hours. Testing, or what is it, 3 hours. Alright, now in order to get here, in this first yellow box, it has to be about 6-cylinder and it has to be about cleaning. So I need 1 hour here, 10 hours overhauling, 2 hours testing. Okay. Cleaning station. Well, now this is about the cleaning station, and it's also about availability. Okay? When we had, come on guys, when we had this in the other section, remember we had totals, but now I've got inequalities, so I've got availability. It does say the word at most. So cleaning at most 9 hours, and at most is a less than or equal to. Overhauling, overhauling is at most 80, and testing at most 24. Now I still have one more bit of information about the 4-cylinder and 6-cylinder, and this is the profit for the two respectively. So my constraints are my inequalities. So first thing you've got to remember, my X and my Y's, guys, either they're going to do this or not, so my X and Y's are going to have to be greater than or equal to 0. So for cleaning, my constraint would be X plus Y less than or equal to 9. And see if you see the other ones. They did ask us to maximize the profit, and if you'll notice, this is the only line that does not have an inequality associated with it. So I want to maximize my profit. So how's that? So I need you to go graph your inequalities. Pause me, go graph, and see if you end up with the same picture I do. So those are my X and Y intercepts for the first linear inequality. There's my second one. But only graph these one at a time. Remember, keep doing that. Now, we've got 3 of them, and this is why it's very important that you graph them one at a time. So I did, but instead of having 3 separate or 4 separate slides, I went ahead and found my feasible region. So hopefully your feasible region looks like mine. So it's that pretty purple, magenta, pink thing there. Now let's see how many corners I've got. It looks like I've got 1, 2, 3, 4, and 5. So go list the corners. Always do the ones that are on the axes first. So this one, let me see, I got my origin, which is 0, 0. I've got 0, 8. I've got 8 zeros, so let's see if I've got that. Okay. Now, to get these other ones, this is why we indicate what these equations are. You need to put this equation in your matrix and this equation into your matrix, because we're after this one right here. And I don't know where that came from. So go ahead and put that in your matrix and see where they hit. So I can get rid of this thing. Interesting. And also do that for the other one. See, this almost looks like 6. What would you say? 3? That's what that one looks like. This one sort of looks like 2, 7. It's off just a little bit. So see if you ended up with 6, 3 and 2, 7. The better your picture is, the better you can double check yourself on your calculator. Okay? Now we've got to put it in our objective function. Remember, that's the last thing we're going to be doing. So we're going to put each one of these individually into that. So you do that for each one of these. And then I need you to see if you end up with what I did. Now we're not done. This is a word problem. We have to come full circle. We've got to answer this question. So this is my maximum value here. So Jim Brown's company, they need to recondition 2 of the 4-cylinder engines, 7 of the 6-cylinder engines, and that will give them a maximum profit of $2,050 with respect to what conditions they're working in under. Okay? So there's some more word problems that you need to do. See if you need to be able to set them up and give me the picture. Okay? Thank you.